Hey everybody, this is a video for my grade 10 MIAP class. This is our first video in chapter 7, which is systems of linear equations. I thought we'd start with something kind of fun here. Let's start with a really tough grade 9 algebra problem. That would be one, that would even be tougher than anything I'd probably put on a unit test in grade 9. Tougher than anything I put in the exam. If you can handle this, you mastered grade 9 algebra. So let's do this as a challenge. Let's have you pause the video and give it a try. Okay, so on your mark, get set, go. How did it go? Let's see. What am I going to do to start this thing? You know what? I kind of am of the opinion that when I'm doing algebra, I'd rather not work with fractions if I can avoid it. So I'm going to get rid of these two denominators. Together, they'd have a common denominator of 4. So I'm going to multiply all three terms, and I consider that a term, and that a term. I'm going to multiply them all by 4. So I'm going to multiply this by 4, I'm going to multiply this by 4, and I'm going to multiply this by 4. So 2 goes into that 4 twice, so I now have 2 times 3, which is 6, which I'll have to distribute into the bracket. Those 4's cancel, so I have 3 times x. And a number times a number times a number, it doesn't matter what order you do it. So I'll do the two non-algebra numbers first. 2 times 4 is 8. It's still a minus. And then 3x minus 1. Okay, so there we go. Mission accomplished. No more fractions. But I still got some brackets to expand. Right? Bedmath says do what's in the brackets first, but I don't know what x is, so I certainly can't take it away from 5 and get a number. So I have a way around that. I can distribute out the brackets. So 6 5s is 30. 6 times negative 2x is negative 12x. 3x minus 8, again, I have to take the negative 8 and distribute it through the bracket. So negative 8 times 3x is negative 24x. And negative 8 times negative 1 is plus 8. Watch out there. A negative times a negative is a positive. Then I think I would like to collect all my x's on this side and all my constants on the other. So I'm going to add 24 and 3x to this side. So I now have 24 minus, or sorry, whoops, that's a mistake. 24x that I added to this side. I'm going to subtract 3x from both sides. And then I still already had a minus 12x on this side. Over here I had an 8, and now I'm going to minus 30 from both sides. And there we go. Mission accomplished again. All the x's on one side, all the constants on the other. 24 minus 12 is 12. 12 minus 3 is 9. And 8 minus 30 is negative 22. So last step, and no, I don't want decimals. I'm sure your grade 9 teacher told you we much prefer fractions in questions like this. So negative 22/9 is my fractional final answer. And then, man, if your grade 9 teacher was as sadistic as I was when I taught grade 9, it would be, well, you're not done until you've done a verify on that. And you'd have to go back and plug this number into here and just pray that your teacher would let you use a calculator to figure that out. But I actually did check this answer. It is right. So feel free to check it if you want. But that's as ugly as it got. That is a pretty nasty piece of algebra for you to solve. So how about we just, for one more warm-up question before we get into today's lesson, let's do a much easier looking one. How about solve that? Again, I'll pause the video, or you pause the video and try to solve that. So how'd you do? Well, bit of a problem here. This is so much easier looking than that. It doesn't have any fractions, it doesn't have any brackets, it's just two little things equals 5. But notice the problem with it. I mean, maybe I solved it and I thought, oh, okay, well, x is 0 and y is 5. That's a solution, isn't it? 0 plus 5 is 5. Or maybe I thought x was 1 and y was 4. 1 plus 4 is a solution. X could be 2 and y could be 3 is a solution. You know, there isn't really one solution for this. But, you know, if you, of course, take all the xy's that I just found, like the pair 0, 5, and the pair 1, 4, and the pair 2, 3, and you graph them on a grid, you could realize that the solution to this is that it's the infinite set of points that makes the line. When you go x is 0 and y is 5, and then you could go 5 there, and then 1, 4 would be here, and 2, 3, and you would get a straight, let's make a bigger dot because I made there, a straight line. And everywhere along this line, this is the line x plus y equals 5, every single point along this line would fit in this chart and would fit in that equation. So you could even say the solution to this equation is this line. Now that might not make people happy. It'd be like, but I want one answer. Well, if you want to get one answer and you have two variables, then what you're going to need is you're going to need two different equations with those two variables, and that is what we're going to start with here. What we've got for this unit is what we call systems of linear equations. A system of linear equations is a set of equations that contain the same variables in the same situations, if it's a word problem especially, that can be solved. So, example 1, we won't do any solving in this lesson, or this part of the first lesson. We'll just learn how to set them up. A school division has two types of buses, a small bus that can hold 12 children and a large bus that can hold 24 children. In total, they have enough buses to hold 780 children. There are 20 more small buses than there are large buses. So I am going to define my variables. I'm going to say let x equal the number of small buses, and let y equal the number of large buses. I can't spell. So now, I see two equations here. Do you see them? They have enough buses to hold a total of 780 children. So now let's see. If I had one small bus, that would be 12 children. If I had two small buses, that would be 24 children. So whatever this x number is, it gets times by 12. And then whatever this y number is, it gets times by 24. And that's how many children I can hold if I have x small buses and y big buses. And I know that this number and this number is a total of 780 children. So there we go. There's my first equation. Now, the second equation comes from the second sentence. There are 20 more small buses than there are large buses. So I can create an equality, and I can say, all right, the small buses, which is x in number, this number is 20 more than the other one. So I could even just kind of translate that from math to English. This is, remember equals means is, 20 more than that, right? So if I put 20 on that side, this balances. And that is what we call a system of equation. These two x's mean the same thing. They mean the number of small buses. These two y's mean the same thing. They mean the number of large buses. And if I were to use the techniques that we're going to learn in the rest of this lesson, the rest of this chapter, I should say, we could figure out exactly how many buses of each kind we're going to be dealing with. In fact, I'm going to put a star by this page. We're going to come back to it and solve the equations that we're making here a little later on. Okay, so remember that. We'll come back to this page. All right, new story. A rectangle has a perimeter of 158 feet. The width of the rectangle is 31 feet. Oh, sorry. Let me finish reading that. I saw a period. I stopped talking. The width of the rectangle is 31 feet less than the length. Oh, that makes more sense. So I'm going to let L be the length of the rectangle and W be the width. Those seem like good letters to use. And, okay, perimeter of 158 feet. Remember how perimeter works? Length, width. There's two lengths and two widths that make up the distance around. So 2L plus 2W equals 158. So there's my first equation. And then my second equation is right here. The width is 31 feet less than the length. Now careful, is that 31 minus L, or is it L minus 31? Hey, if I were to ask your age, and you said, this is my age, and I said, okay, what's 3 less than that? Would you go 3 minus your age and get a negative number? No, you'd put the age first. So it's the length minus 31. And that's the two equations that represent this situation. This is a linear system of equations. Why is it linear? Because nothing's being squared here, right? These, if I wanted to graph these things, I can graph them with straight lines. Example 3. A school raised $140 by collecting 2,000 cans and bottles for recycling. The school received 5 cents for a can and 20 cents for a bottle. So this one's a little tricky. Notice that there is two facts here, a monetary amount and a total number of counted cans. If I let C equal number of cans and B equal number of bottles, notice what I can do here is I can say, all right, well, there's 2,000 altogether if I add the cans to the bottles. So that's the first equation. And the other equation I can get from the money. Now remember, every can gets me 5 cents. So 5 cents times the number of cans plus 10 cents times the number of bottles. And oh, if I were to just write, you're probably thinking equals 140. I got it. Now look at it carefully. Why am I not writing 140 here? You see what the problem is with 140? What kind of unit is that in? Cents, dollars. See what I had to do there? Change dollars into cents. And there we go. There's our third example. So the first part of your homework for this this lesson is going to be just a few questions from the textbook that ask you to do exactly what I just did. Look at a situation and see if you can come up with a system of equations that describes it. Then what we're going to do next, since that was so short, is talk about what it means to find the solution to a system of linear equations. Well, the first way we're going to solve is we're going to solve graphically. So the solution to a system of linear equations is the coordinates of the intersection point of the graphs of their lines. So if I take the two equations that I had in all those three situations there in 7.1 and I graph them all, wherever they meet will be my answer. So if you look here, I've got 2x minus y equals -4. That's this line here, right, with the positive slope, right? Because think, if I move this 2x to the other side, divide by a negative, it's going up. It's a positive slope. Then I have the equation 3x plus y equals -1. And according to this graph, if I'm reading this properly, when x is 1, -1, sorry, can't read. If x is -1 and y is 2, that should be the solution. Now I want to verify that that's true. So here's how I verify it. I go, okay, if this is, of course, remember that that's the point xy. If x is -1, I plug it in here. And if y is 2, I plug it in here. And that should be a true statement. And let's see, is it a true statement? 2 times -1 is -2, minus 2 more is -4. Yes, it is a true statement. It should also be a true statement here because this point is on both lines. Fancy terminology, this coordinate set, or this point, satisfies both those equations. That's the word we usually use for this. So it satisfied the first one. Does it satisfy the second one? Does 3 times my x is -1 plus 2 make -1? And as you can see, yes, it does, because -3 plus 2 is -1. -1 is equal to -1. Yeah. So that's it. That's the solution, and I just read it off the graph. Now, it probably doesn't take you long to see the drawback to the graphing method. First of all, you need graph paper. Second of all, what if it wasn't exactly right on the coordinates there? What if my answer wasn't whole numbers? That first equation we solved as our warm-up there, it was, what was it, -22/9? That's not every answer to a system of equations is going to be nice integer for us to find on a grid. But this is still an important skill, so we're going to practice it a bit. So let's do it again. This time they're not being nice to us and giving us the equations, so let's figure out the equations for ourselves. Let's take this first one here. This first one here has a y-intercept of 5, and it has a slope. Let's count its slope from dot to dot. Remember, I always use the dots they give me because those are the dots I'm sure of. So my dot to dot here goes from, let's say I go up 5 and over 5. So I have a slope of 1. So that means y equals mx plus b, remember this from last unit, is y equals 1x plus 5. So there, that equation there, that line there is y equals x plus 5. Let's do the other one. The other one has a y-intercept of 1, and its slope goes down 1, 2, 3, 4. So my slope is negative 4 over, so 1, 2, 3, 4 over 1, 2, 3. Oh, it's negative 4 over 4, which is negative 1. So y equals mx plus b would be y equals negative 1x plus 1. Okay, so there's my two equations. Now, what is the solution of those two equations? What is the place where the x and the y are the same value in both equations? Well, according to this graph, if I read it properly, and let's see, let's not mess it up this time, negative 2, 3. All right, let's see if that's true. Let's verify it. If, we'll do this one first. If y is 3 and x is negative 2, do I get a true statement? Yes, I do. 3 equals 3. It works for that one. Let's try it for this one. If y is equal to 3 and x is negative 2, now careful here, it's the negative 1 times x, so that's the negative of negative 2, which is positive 2, right? The negative of a negative cancels. And then plus 1. And yep, 3 plus 3. 3 is equal to 3. So that's a true statement. So yep, that one works. So there it is. There's the solution. Pretty easy. Okay, couple more. This time, we're not even giving you the pictures. We'll give you the equations, and you got to graph them. So feel free to pause the video and give this a try for yourself. If you don't have the ability to print this, by all means, just take out graph paper, make yourself a grid, make it about 10 by 10, graph this thing, pause it, and give it a try for yourself, and then I'll be back with you in a sec. Okay, you got two lines, and do you think you know where they met? All right, let's see. How do I want to graph this? How do I graph the? Let me check the ways. Well, here's what I'm thinking. I'm going to use the y equals mx plus b method because I noticed right away 2 doesn't go into 3. So if I wanted to use the intercepts method, it'd be messy here. I'd be dealing with fractions. So for this one, I'm going to change it to y equals mx plus b. And for that, I'm going to say, okay, so that means y is equal to, if I move the 2 to the other side, it becomes negative 2x. And then if I divide, then there's a 3 on the other side, right? So plus 3. But then I have to divide both sides of the equation. Maybe I'll do it in 2 steps. So I move the 2x to the other side by subtracting. And then I find a sharper pencil because this one's getting on my nerves. And so there we go. Y is equal to negative 2/3 x plus 1. There we go. So plus 1. And then down 2. And over 1, 2, 3. Looking good. Get a ruler on that. Let me double check that I counted right. 1, 2, 1, 2, 3. Yeah, that looks good. Okay, so you make straighter lines when you make sound effects. I don't know if you knew that or not. All right, what am I going to do with that one? I think this one I might use the intercept method because 1 and 1 both go into 4. So the intercept method is what happens when x is 0. When x is 0, y is negative 4. What happens when y is 0? X is 4. So 0, negative 4. So 0 over and 4 down. Right there. Did I count that right? 1, 2, 3. Yeah. And then 4 over and 0 up. 1, 2, 3, 4. I think they're going to meet right there. Let's see. I'll graph that. And I think the solution is, I don't know. Now, I'm thinking it's 1, 2, 3, negative 1, but it's I'm a little bit off. Now, is that because maybe when I made zhunk sounds and made my graph here, I was off a little bit? I really thought the zhunks would make my graph nice and accurate, but it doesn't look like it did. So I'm going to say that I think it's 3, negative 1, but you know what? I better check it. So let's see. Does 2 times 3, which is 6, plus 3 times negative 1, which is negative 3, equal 3? Yes, it does. Okay, so it satisfies the first equation. Does it satisfy the second one? When x is 3, minus negative 1 Do I get 4? Yes. So you know what? That is the right answer. This point is off because we just talked about this. That's the limitations of the graphing method. I am at the mercy of how accurately I can draw. Of course, a graphing calculator or a graphing software program doesn't have that limitation. If I type in 2x plus 3y equals 3, I get that line. And if I type in x minus y equals 4, oops, equals 4, there we go. I get that line. And as you can see, I just even have to hover on it, and yep, it is the point 3, negative 1. So let me go back to my work here. This is one way to write the answer. You know, the other way I can write the answer is I can actually say x equals 3 when y equals negative 1. I don't really care how you write the answer. That's in coordinate form, and that's as a solution. You know what? If this was a word problem, like what we did in 7.1 a few minutes ago, I'd kind of want something more like this. But in a situation where you're just telling me a point on a graph, write it as coordinates. Don't mix up x and y, though. In the last test, I noticed some of you are still mixing up x and y. All right, one more. Let's play the game again. Pause, graph, and get back to me. How'd you do? All right, I think for this guy, I'm just going to change it to y equals mx plus b. It's a simple move. I just got to move the 2 over. So start at 6. 1, 2, 3, 4, 5, 6. Y-intercept of 6. And then my slope here is, of course, negative 2 over 1 is my slope, right? So I go down 2 over 1. And this time, I'm going to try to be more accurate. I'm going to make more points. Down 2 over 1, down 2 over 1, down 2 over 1. Okay, that's... I'm already tired of making points. That's good enough. Maybe a different noise this time will make a more accurate graph. What do you think? This one, I'll use the coordinate system again for this one. So when x is 0, y is 4. When y is 0, x is 4. That's pretty easy. So I go through 1, 2, 3, 4, and 1, 2, 3, 4. And let's see, where are we crossing here? Yep. We are crossing, I think we cross right here. I think that's my winner. I think it's the point 2, 2. Let's do a check. Does 2 times 2 plus 2 make 6? Yep. Does 2 plus 2 make 4? I'm not even bother writing it. Yep. So there we have it. That is the first couple of sections in Chapter 7. Check my blog and I'll have a little homework assignment for you from the textbook. Thanks for watching, everybody. See you later.